Welcome to AP Physics C. My name is Zihan Guo. Yiling Wang and Xiaoxi Mo are my partners. And the core idea of our experiment comes from problem number 1 of 2008 AP Physics C, Mechanics Free Response Exam. And this is where the problem comes from. In our experiment, we will testify how well a mathematical function can predict the outcome of a real-life physics experiment. First, we will prepare a cart attached with a cardboard to increase surface area, which will then increase the impact of the drag force. We're not going to use a skier because it's summer, it's springtime, and it's very hard to find snow and a skier. So my team members and I agreed. This is a cart designed by one of our team members. As you can see in the photo, there's a string attached to the surface area to support the flag, the plane. And let's do a force diagram for. So imagine the skier is a cart. We have the weight G equals to mg and F normal force, which is perpendicular to the ramp, and the drag force, which is as the opposite direction comparing to the skier, to the cart. If we separate the magnitude of G equals to mg into two components, one is vertical to the ramp, one is horizontal to the ramp, we will get mg cosine theta. This is the value of theta, mg sine theta, which is in horizontal position comparing to the ramp. Then we can conclude F normal must equal to mg cosine theta, which is vertical, whereas F net has to equal to mg sine theta minus bv. Where does bv come from? bv is the drag force defined by the core problem, and F net is the net force. Alright, here is how the math works. We know F net equals to mg sine theta minus bv according to the previous slide. And according to Newton, a mathematical genius, F net equals to ma, where a equals to dv over dt. So m times dv over dt equals to mg sine theta minus bv, whereas m times dv equals to mg sine theta minus bv times dt. The integral of each component will lead us to this function. This integral, I mean. And here's the tricky part. Minus 1 over b comes from exists because of the chain rule. Yeah. We then integrated this integral, and this is what we have. Please take your time to go through this process. I'm not going to go step by step in this slide. But as you can see, once we find the general equation, we have to find the value c. And how do we find it? Is by just finding a point. At time t, velocity equals to t. So c automatically equals to mg sine theta. And then we plug the value of c back into the equation, and this is what we get. A function of velocity at any given time t. Awesome. However, in our experiment, we have to find the value of b in order to find the accurate function. So how do we find the value of b? The way that we find it is by finding the terminal velocity of the cart. And as you may remember, once the cart reaches terminal velocity, the mg sine theta, which is a horizontal force, applied to the cart on the ramp will equals to BV terminal. Then the terminal velocity will equals to mg sine theta divided by b. So in our experiment, we find the angle theta, the mass of the cart, and g is given by 9.8. We used a motion detector to find the terminal velocity, as you can see in the next slide. As you can see in this graph, the average value for the terminal velocity is 0.6 meters per second, as shown in the graph. This part. Alright, so we plug in the number into the function after measuring the mass of the cart, the angle of the ramp, all the experimental value that we need. Then finally we find the value of B, which is around 0.259233. The equipments we used are photo gates, angle ruler, electronic balance, and 3 very smart brains. Now we can plug in all the values of each variable, each factors, into the function, which we get here. This is a function, this is a velocity function in terms of t. So, is this mathematical function accurate or not? We derived this function by using first order differential equation. However, is this really accurate? So, what does physics say about this experiment? By using the motion detector, the computer would able to accurately provide us the information about the velocity function, the velocity graph. As we can see, when at time t equals to 2, the value is around 0.399, and after we plug the value of 2 into the velocity function, which we derived using first order differential equation, that equals to 0.37, which is very, very accurate. So we calculated the error, the percentage, the error, the experimental error percentage, and we find the value is around 7.2%, which is fairly accurate. So what caused the error? Our team members concluded that there are 3 factors that actually influenced the result, the outcome. First, the value B is not very accurate. We find the value of B by finding the terminal velocity. However, because of the imperfection of the equipments, the value B may not be perfectly accurate. Also, which is the second factor, which is also the most important factor among all, is the drag force. The accurate function for drag force is actually half times rho, which is the density of the fluid substance, times velocity squared times the drag force coefficient times A. A is the surface area. So as we can see in the drag force equation, the drag force actually is proportional to velocity squared, not directly proportional to velocity, and this is a huge factor to our results. However, 7.2% is fairly good enough. Alright, so this is all of our project. Thank you very much for your time, and have a great summer.